Solutions to the midterm diagnostic test. Question 1. Bob is buying food for a school barbecue. The budget for the meat is 500, sausages cost 50 cents each, and the steaks cost $1.50. Part A, identify variables and parameters. So Bob's real question is, how many sausages and how many steaks should I buy? So let S, so this is under the heading variables. Let S be the number of sausages. And let, I got S as well, I'll let T be the number of steaks. I also need to find what the parameters will be. So the parameters is basically getting all the information from the question. So cost of sausages, you might want to do this in a table, but either way, 50 cents. Cost of steaks, $1.50, and total max cost is 500. Okay, so that's part A done. Part B, write a constraint that shows all possible combinations of steak and sausages. So remember, constraints are combining these two together. So writing the parameters in terms of the variables. The total cost, I'm going to buy S sausages and T steaks. So S sausages will cost me 0.50 S. T steaks will cost me 1.50 T. Okay, I also know that the total max cost is 500. So my constraint will be 0.5 S plus 1.5 T. So that's my total cost. Needs to be less than or equal to 500. And I could graph that if I wanted to. That's all question 1's asking for. So you need to carefully read the question and make sure you're just doing what the question asks you to do. Question 2 is another example where some people would have done a lot more work than they were required to. So a factory must make at least 150 items per week to fulfill its orders. To keep the factory running effectively, no more than 2 junior staff and 4 senior staff are needed. In 1 week, a senior staff member earns 1,050 and can make 15 items, while a junior earns 580 and can make 10 items. So it says state the variables and create an objective function for wage costs. Okay, so in part A, state the variables. So in this factory, the 2 things we're thinking of changing are the number of junior and senior staff. So I'll let J be the number of junior staff. And may as well let S be the number of senior staff. And it says create an objective function for wage costs. So I've got my variables. I need to make an objective function for wage costs. So I'm only going to list the parameters for wage costs. So I know senior staff member earns 1,050. And the junior earns 580. That's the only information in here that relates to wage costs. So I need to create an objective function for wage costs, which is basically a formula for the wage cost. So I'll let capital W be wage costs, and just need to make a formula for how much it'll cost altogether for J junior staff and S senior staff. So my objective function will be W is, well, J junior staff at 580 each, so 580 times J, and then S senior staff at 1,050 each, 1050 S. Okay, so that's done. I've got my variables and I've got my objective function. Part B, should the function be maximized or minimized? Okay, so for part B, should we maximize or minimize the wage costs? I would say that we should minimize it. And it says give a reason for your decision. Okay, my reason would be that I want to maximize profit. Okay, so because I'm running the factory and I want the maximum profit, need to make sure my costs as low as possible. Okay, so that's the question done. Okay, again, read the question, make sure you know what these words mean, variables, parameters, objective functions, so that you're only doing what the question asks you, otherwise it'll take you forever to do the exam. Final problem, problem 3, requires you to do the whole thing, to go through the whole process and actually find an optimum profit at the end. So read the scenario. Babette knits hats and socks to sell at markets. Hats take 15 minutes to make and socks can be made in 10 minutes. She knows she can sell at least 80 items per week, okay? All types of hats and socks, but she can only afford to knit for 16 hours per week. Babette can make a profit of $3 for socks and $5 for hats. Okay, so part A, construct the constraints and draw the feasible region. If I need to construct constraints, I need to start by defining some variables. Okay, so I'll let H be the number of hats, and I'll let S be the number of socks. Okay, I better list the parameters in a meaningful way so that I can follow what's going on. So I'll put these in a table, hats and socks. So she tells us things about the time that she has available. Hats take 15 minutes to make, so I'll put my time in minutes. And socks take 10 minutes to make, and total time she has is 16 hours. So whatever 16 times 60 is. A total of 960 minutes. So I'll tick this information off as I've used it. Okay, Babette can make a profit of $3 for socks and $5 for hats. So I'll put this in here as well. All in my table. And what else do I know? Sell at least 80 items per week. Okay, so there are all the parameters. So now I need to actually construct the constraints. So I've got a constraint for time. Okay, and I'll find that by reading this column of the table. So my total time that it's going to take to make H hats will be 15H. It'll take me 10 minutes to make S socks, and I know that that can't be bigger than 960. The other constraint I have is a minimum number. So I know I need to sell at least 80 items per week. So something needs to be at least 80, and it'll be the total number of items. So my H hats and S socks. And just to make sure that I don't end up with any negatives, my number of hats and my number of socks need to be at least 0. Okay, so construct the constraints. Here they are, done. And I now need to draw the feasible region. So you should be pretty good at drawing the feasible region by now, finding the H and S axis intercepts. So I won't go through that, I'll just draw the feasible region at the bottom. So I've got my 2 graphs on the same set of axes. I need to be less than this one, so below this one and above this one. So what that'll end up is with me shading this area in here. Okay, and I'm trying to, so what have I done? Part A, that's done, draw the feasible region, done. B, find the objective function for profit. So in part B, the objective function for profit, so I'll let P be profit. My profit will be 5H plus 3S. Okay, and I want to maximize this profit. I want to make the most money I can. So what that means is that I'm going to be looking at the vertices or the corners to try and find where my maximum profit will occur. Okay, so I'm going to be looking at these 2 points. Okay, the ones that are furthest away from the origin. So this point is 0, 100, and this point is, well, it's pretty hard to read off the graph. Apparently 32 and 48. Okay, it's obviously pretty hard to read that off the graph, so you probably have to use your graphics calculator to find this intersection point. Okay, so if I was trying to do that, I've got these 2 equations, 10H plus, correction, here are my 2 equations. I need to rearrange both of them for whatever I have the vertical axis to be, so I get S by itself. So take 15H and divide everything by 10. Over here, it'd be a little bit easier. Get S by itself. And then these 2 equations I'll put into my graphics calculator. Okay, writing X's instead of H's. So 960 minus 15x on 10 and 80 minus x. So I'll draw these, probably won't be able to see anything. So I'll try and zoom, F2, auto, see if that shows me it. I can sort of see what's going on now, maybe need to zoom out again. Yeah, keep zooming out until I can see what's going on. So I'm looking for that intersection point in the middle. So I'll G-solve F5 and find the intersection point. And it tells me there that it's 32 and 48. So in the exam you can do this and write that you got it from a graphics calculator. Okay, otherwise you're going to be guessing to try and find that point. Okay, so I'm trying to find what the optimum profit's going to be. So I'll make a little table with my number of hats and number of socks. Okay, and I'm trying to evaluate what the profit will be. So my ideas were to make 0 hats and 100 socks. Okay, that guy. Or to make 32 hats and 48 socks. So to find the maximum profit, I really just need to find which one of these 2 is going to give me the most profit. So in here, I'm putting it into this profit function. So 5 times 0 plus 3 times 100, give me a profit of 300, and then doing the same with these H and S values should give me a profit of 304. Okay, actually made a little mistake. That point isn't 0, 100, is it? It's actually 0, 96. Okay, so it should be 3 times 96, okay, which will get me 288. Okay, so my conclusion will be to make the maximum profit, okay, we need to make 32 hats and 48 socks for 304 profit. Those of you that are hoping to get A's, you can obviously find the intersection point using substitution or elimination. Okay, so these are the 2 ways you could have gone about it, and practice that skill. It is, I think it's lesson 8. Yeah, you can watch the video for lesson 8, which goes through how to do substitution and elimination.